In stats, we took the idea of random variables further and we talked about standard deviation. So we have this formula for variance where we take each x, subtract the mean from it, square it, and multiply by its probability. So that one is not on the formula chart, but this one is for standard deviation. You just square root what I just wrote down. And we're going to practice it. It may look daunting. It's not that bad. It's just a little tedious, a lot to write down. So the mean from the APGAR problem was 8.128, and we're going to use that to get the standard deviation for the APGAR scores. So let me scroll down a little bit and we'll try it out. Need some space here, and you want to go slow. You got to go right off that formula. So I start by writing the variance down, and we're going to go term by term. So there are 11 terms here. I'm not going to write every term down, but I will write a lot down. So we're going to go 0 minus the mean, square it, times 0's probability. Here, let's do another one together. 1 minus the mean, square it, times 1's probability. Maybe hit pause and try to write the next couple terms. Here, we'll do 2, and then I'm going to do ... for the rest. So 2 minus 8.128 times 2's probability. And then I am A-okay with you, and so is AP okay with you writing ... on a large table like this. Let's write the last term. And 10's probability. So what I am going to do next is I'm going to pull up what I wrote down in class the other day for each term. That way, if you're doing this at home and you get the wrong answer, I want you to see what each term should be. Now, if you're careful with the calculator, you can type this whole thing into one long line. Use parentheses, be careful. The downside to that is if you have a typo, it's hard to find that typo. So it's up to you how you want to do it. All right, so there is each term for the variance. And then for the very last step, you need to square root 2.0658. And there is some of it. So you square root 2.0658 and you get that standard deviation. And we also needed to interpret it. So I wrote down my interpretation. And there's the whole problem. All right, remember a standard deviation is a form of an average. So there you go. Make sure you use context. We'll try more of this down the road, but we're going to look at a completely different type of problem now. So we're going to move to continuous random variables. They could ask this using the normal curve, which you guys are very familiar with. They could ask this using the uniform distribution, which is a flat line. And you use rectangles to find the area. Or probability, I should say. If it's a linear function or piecewise function, it could look pretty wild. So this one is nice and basic. You know, if they asked for the probability of this value up to this value, whatever this is, you would need to find the area of a trapezoid. They could make it even more complicated and make it a true piecewise function where it does something like this. And then you might have to segment off some areas, because if they want from here to here, there's no geometric formula that'll get that. So you would need to maybe segment this off right here and get these areas and add them together, and you could get that. So they could get real complicated, like in terms of the geometry, but don't worry, we're not doing any calculus. So let's look at a uniform problem. So they tell us that this random number generator is generating numbers uniformly. The numbers can be anywhere from 0 to 1. Since it's uniform, it's a flat line. So this word right here tells us it is a flat line for the graph. They're also nice, and they tell us it's 1 unit high. And there's our graph. They want to call this variable y, so it's kind of weird. This axis is called y, which would then naturally make this f of y. So when they want the probability between 0.3 and 7, let's shade that area. So guess where 0.3 is, guess where 0.7 is, and let's shade that space, area under the curve. Isn't that a rectangle? And the area of a rectangle, here, let me write this, area under the curve is probability. So since it's a rectangle, we could do base times height, and I know that base is 0.4, right? 0.3 to 0.7, and the height is 1. So the answer is 0.4. Kind of nice. All right, let's look at another problem that should look very familiar. It's more review than anything. And that is a normal curve. So back when we did this in October, we actually were doing random variables. So this page is kind of nice. It's review. So take a moment, read through it, maybe hit pause. Remember, you need to define the distribution. Oops. And this variable y is normal, as they say in the paragraph, with a mean of 64 and a standard deviation of 2.7. So those are points right there. You need to write that down. Next, you need to write the question. So probability of 68 to 70. Those are points also. Make sure you write that. Since it's normal, you need to find each value's z-score. So remember, a z-score, where could I write this? A z-score is the value in question minus the mean over standard deviation. So we're going to go minus 64 divided by 2.7. And when we do that, we get 1.4815. Let's get 70's z-score. And we get 2.2 repeating. And then this is the part where some people were confused. We're going to grab our calculator. We're going to find normal CDF. To get the probability. So if you have a calculator handy, you need to press Menu, Stats, Distributions, and then Normal CDF. The low should be 1.4815. The upper should be 2.2 repeating. Leave the mean and the standard deviation alone. Because since we went to z-scores, the mean is 0, the standard deviation is 1. And the final answer should be 0561. Maybe hit pause and try and do the second question on your own. Probability of being shorter than 62 inches. Did you get that? I hope so. So find 62 z-score, go to normal CDF. This one's tricky because the low has to be negative infinity, which is why I wrote negative 999, and you should get 2294. And look at the third question. Don't you already know the answer? It's 2 units above the mean. The previous question was 2 units below the mean. Isn't it the same exact answer? Remember, the normal curve is symmetric. I mean, you can find 66's z-score. It's going to be 0.7407. Do normal CDF again. Flip that low and upper, and you get the same answer. I hope that made sense. I will see y'all later. Bye.